Hey, Mr. Harridan here. We're going to go over using concentration, which brings up the question, what is concentration? Besides deep thinking, deep thoughts from Mr. Harridan. But no, concentration is the amount of substance per defined space. There are many ways to measure concentration. Some people do mass-to-mass solutions. Some people do mass-to-volume solutions. Some people use molarity. Some people use molality. Those are physics people. Some people use mole fraction. There's a bunch of ways to measure concentration. The one I'm going to go over with you today is molarity, which is the big M. Okay? This is the number of moles of solute per liter of solution. The formula for molarity is moles over liters. That is the one that is on the formula chart. We also have what I call the Eric-Yates version of the equation, which is the one that Eric Yates prefers, of course. If you don't know who Eric Yates is, well, anyways, he's close to being a legend himself. Okay, he uses the formula mass over molar mass divided by liters. This one is not on the formula chart. So if you want to use this one, better memorize it. Not on the formula chart. Okay. The units for molarity is the big M, or you can also write moles per liter. So if I was to make a solution, let's say I'm making a 2 molar solution of potassium nitrate. What I would have to do is measure out 2 moles of potassium nitrate and dissolve it in 1 liter of total solution. Okay, to make a 2 molar solution. Now, to actually physically do this, okay, the first thing I would have to do is use my calculator. Okay, because there are no scales that measure in moles. Okay, so I have to calculate out the number of grams of solute I need. Okay, then I would use a scale to measure the mass of the solute. I would use my good friend the volumetric flask, because the volumetric flask is a precise way for making solutions. It is the best way. I would put a little bit of powder in it at the bottom, add water up to here, mix it around a little bit, and then add more water to the line, and then I would mix it some more. And that's how I would make a 2 molar solution. So molarity is the most common way of expressing concentration of solutions. If you increase the molarity, that means the solution has become more concentrated. That's what it means. Okay, let's go down and look at the problem here. How many grams of sodium hydroxide is used to make 500 milliliters of a 2.5 molal solution of sodium hydroxide? So right away I see that this is the molarity. Okay. Here is my volume. Now this says 500 milliliters. I'm going to convert that to liters in my head, which is 0.500 liters. I'm looking for grams, which is the mass. So if I use the Eric-Yates formula, molarity equals mass over molar mass over liters. This is 2.5 equals mass. Okay. The molar mass of sodium hydroxide is 40.00. I have that one memorized. You can figure it out with the periodic table. And then this is 0.500 liters down here. This is the big M. Okay, so what I do here is I multiply these two first. Okay. As I try to find a calculator. I get 1.25 mass, and this is technically 40.01, but whatever. And I do that cross multiply again, and then eventually I get a mass of 50 grams. This has two significant figures because 2.5 only has two significant figures. Okay, how would I go about preparing the solution in the lab? Number one, I would measure 50 grams of sodium hydroxide on a scale or balance. Add sodium hydroxide to volumetric flask, because that's the best way to make solutions. Carefully. Add some water. Mix. Okay. Add more water to line, then mix more. I forgot to conclude the size of the volumetric flask. Usually, there are 500 milliliter volumetric flasks. You just find one that has 500 milliliters on it. Sometimes you only have like a liter volumetric flask, so then you would like double the numbers and all that fun stuff. Okay, let's go on and look at the next problem. Page 16. 35.8 grams of lithium hydroxide are dissolved to make enough water to make 750 milliliters of solution. What is the molar concentration of the solution? Well, I'm looking for molarity. So molar, that's how I abbreviate molar sometimes, is equal to moles over molar mass over liters. No, it's not equal to moles, Mr. Harridan. It's equal to mass. That's what you get for using the Eric-Gates formula. Okay, so 35.8 grams of lithium nitrate. Lithium hydroxide. The molar mass of lithium hydroxide. Let's see, I know that one off the top of my head too. It's 23.95. Again, I found that using the periodic table. And then I'm going to divide that by 0.750 liters and get an answer. Okay, since I have two significant figures in my 750 milliliters, the answer to this is 2.0 moles, or molality. You could also write it as this, 2.0 moles over liters. Okay. Usually you'll see me write it that way. Usually. Okay, 40 grams of sodium chloride are used to make a solution whose molarity is known to be 0.50. How many milliliters of solution do you have? Okay, so the formula we're going to use here is molal equals mass over molar mass over liters. Okay, so we have molal is 0.50. The mass is 40 grams. The molar mass of sodium chloride, again, you can figure this out using the periodic table. And I do not have that one memorized, believe it or not. So I have to take a second to figure that out. 35.45 plus 22.399, I think. Oh, yeah. Should be 58.44, isn't it? By Jove, it is. I knew that. Come on. That's the messiest 58.44 ever. 58.44 grams per mole. And we're looking for the liter, so I'm just going to put that as an X down here. So the way I would solve this, of course, is switcheroo, kangaroo, Scooby-Doo. That's how I would solve this. So then X is equal to 40 divided by 58.44, which is divided by 0.50, and I just type it in like that on the calculator. And I would get 1.368 liters, because my answer comes out in liters. And then if I was to round that for sig figs, I would convert that to 1368 milliliters. And if I was to do sig figs on this, which I shouldn't, but I will, the answer is 1400 milliliters. Okay. You guys are champions. The legend is out.